Mr. Green, we're having a quiz on it right now? No, not right now. Maybe later today. Not this today, but maybe later this week we will have it on another quiz with something else. Only reason I said I was having it today is to freak Josie out because she'd come up and, oh, I forgot. So I could see if I could get her, so I could see her get fired up. But shut up. You'd hear me if you quit talking. Thank you. Now your tests are graded and recorded. Okay? If you're one of the 3 people that haven't finished yet, freaking get it done. Before school, after school, lunchtime. Free period, that'd be fine. Your prep period, Mr. Graham? That's great, I don't care. Just get your butt in here and get it done. Okay? After that, we'll pass them back, and away we go. So today, we're talking about central tendencies and measures thereof. Now, why do we care about them, Mr. Groom? Because I don't care about everybody particularly. I don't really care about the average, the strange person in the room who, like, okay, for instance, the principal comes to me, Mr. Groom, this kid is failing your class. Yeah, I know, he never comes to class. He doesn't turn anything in when he does come. But what can you do to help that? No, I'm not his parent. But don't you think no, I just teach. And I'm here. If they don't want to come, they don't want to come. That's fine. I don't care. But Mr. Groom, for crying out loud. So I kind of just throw them out in my mind of the data because it's not really my thing. Now, as a principal, of course, I have to show that I care. So I create some program to help those folk that don't come to school and whatnot. And we'll come and not only will we bring you a bus to come pick you up, we'll wake you up and everything. It'll be great. It'll be awesome. Like you can just be a complete buffoon, and it'll be awesome, and that's fine. That's not my job. So Mr. Green looks at those and kind of goes, not to worry too much about them because I can't control that. But I do care about the quote-unquote average person. Can you 3 just shut up? Because if you can't, sit somewhere else. Thanks. Now, the average person, quote-unquote. Now, if you read the book, of course, you know the average. By average, he means what? There are several things he could mean. What? Say it. Yes, I know you read 1 or 2 pages. You even told me that. Like the whole median thing. Okay. Well, I don't know. Sure, why not? Let's go with median. Median is nice. Why median? Why do we like median? Because it's the middle number. And what does that mean to me when it's the middle number? We also said, if you were paying attention last week, we said it's the 50th percentile, which means that what? That means 50% are better and 50% are worse, yes? Mm-hmm. Why is it better than the average sometimes? Why is it better than the average sometimes? You're really getting on my nerves, woman. This is not like from the textbook. This is not from the book. You learned this in like 4th grade. Because you're the one that said I didn't read it. Shh. Now, listen. This is a big deal. The median is unaffected. Unaffected by extreme values / outliers. If you have the median income in St. Helens, and then Bill Gates moves to town, absolutely not one bit does he affect the median income, because he's one dude on the upper end. On the extreme upper end, yes? But he's just one dude. So the middle number is still going to be pretty much where the middle number is. Might it bump up like a few dollars or something, I suppose, perhaps. If the middle number was here, now it's over just a skosh, and the next guy over makes a few bucks more. But it's not wildly affected. Not like adding Bill Gates' income in and then dividing, because that would be a bigger deal. What were you going to say?
I was going to say it's like the same thing as adding just someone else's income that's still up there, just not as high as Bill Gates, because it still does the same thing to the median, right?
Correct. Yes, correct. Exactly. So one value on the upper ends or lower ends does not hurt us at all. Doesn't really change much. Right, exactly. But it's really the big deal about the extreme is the big deal. The extreme and the outliers. That's the big deal. If you just had a normal set of data, Mr. Groom, I feel like you're a little taller than average. I am a little taller than average. So I feel like we put you on the upper end and we just added you to our data set of just regular normal people. I feel like your height really wouldn't affect the average that much. You're right, it really wouldn't, because I'm really not that tall as things go. But Mr. Groom, what if a guy if Manute Bol walks in the room, what was he, 7'6" or something? Would he affect the average? Yes, because that's weird. Mr. Groom is tall, but not abnormally so. No one goes, oh my gosh, Mr. Groom, you're so tall. No, not really, just normal size-ish. A little on the upper end of normal? Yeah, okay, but not really weird, okay? Lindsay, how tall are you?
5'7".
She's like 5'7". I always feel like she's a little taller than that. I don't know why. She just has that taller vibe about her. I don't know why. Do you wear heels frequently? Oh, maybe that's it. I don't know. I really don't pay attention to these things, okay? But the point is this. When you look at some people, you're like, oh, they're a little taller than normal, I guess. Maybe a little shorter than normal, whatever. But in the middle-ish. They're not normally weird. You know, you see a 5'10" girl, you're kind of like, oh, she's tallish. Whatever. You see a 6'5" girl, you're like, whoa, holy cow, that's weird. Okay? And as a result, yeah, it pulls that average towards it. Same thing could happen on the lower end as well. We like this. We are going to look at this quite a few times this year in reports. The government always puts out things like median family income. It puts out things like median home prices. And again, for the same reason. Somebody moves into a little town and they build a new house. And it's like a $6 million house. But every other house in town is like $120,000. All of a sudden, the average home price is ridiculously expensive. I mean, it's like $200,000 something. You're like, what, one house? Yeah, because there's not that many houses in town. Okay? For instance, the town I grew up outside of, this one guy built this huge, big old mansion thing up on the hill. All right? And it looked ridiculous. Okay? Everybody else lives in the little town, and there's not that many houses in the little town, and they're all like shacks. Okay? And they're not very nice. There's a couple that are okay, but they're just kind of shacks. And then there's this mansion up on the hillside. Okay? If you'd have taken a sample like 30 or 40 homes, and you found the average, and you included that one in there, wow, that place looks like it's really fancy, because the average home price had been like $250,000 or something, or more, if you would have included him in the sample. And yet, if it's just a median, you're like, oh, look at that, it's just another price up there on the upper end. Doesn't really affect the middle at all. Okay? Same thing's true with family income. Like, again, it's just the whole idea of just one person can make a big difference if it's extremely high or extremely low. Again, if you move to Lake Oswego and you're a person who works at like McDonald's part-time, that's your job, and somehow you're living in Lake Oswego, maybe in a tent, I don't know what you're going to buy in Lake Oswego if you work part-time at McDonald's. But if you were included in the average, your income would drag the average income of Lake Oswego down by quite a bit. Lake Oswego being a pretty ritzy part of town. So anyway, of course, we talked about means as well. The straight up average. And we know how to find them. By the way, I like to write it like this. In this book, we will write it like this. It's not gross.
It looks ugly.
So X bar, just that's how you say it, X bar. So when you see X bar, that is the sample average. Sample average
Is the X bar?
is X bar. There's an A in there. That is what X bar is. And how do you do it, Mr. Groom? Well, you sum. That's what sigma means. Sigma means add them up. Add up to what, Mr. Groom? The X's. But what's with the I? Because if they're people's ages, there's a bunch of ages, yes? How many ages? I suppose there's n of them, yes? So you're going to add up n of them and then divide by the number that there are. This formula is no different than you learned in 3rd grade, except I wrote it different. Okay? This is how the big kids do it, because later on we're going to have a couple other formulas that come up and they look very similar to this. It's a skosh different though. Okay? But we will use this sigma thing a lot. Sub I. Listen, dear. Do we all have a last name? They're all different though, aren't they? Yeah? Unless you're Cher Beyonce. Everybody else has a last name, okay? But they're all different last names, yes? Everybody in this room has an age, a weight, or whatever. Yes, but they're all different, are they not? That's just what this sub I means. So they're X's, they're all ages, weights, whatever they are, but they're mine, yours, and somebody else's. How many are there? There are n of them. So you're going to add up from 1 to n of them. You're going to add them all up, divide by the number that there are. That's all that means. Oh, it's a I. I equals 1 to n.
Wait, what's the little like box next to the X? It's an I?
That's an I, yo.
That looks like an eye. There you go.
Big enough? Get an old man font going on. Nice. It's amazing how easy your stuff to read is when it's in a normal size font like that. Nice. Somebody a while back gave me a book that was in large font. And I'm like, really? And they're like, well, it's just a book that I had. I thought you'd enjoy it, but it's in large font. Were you trying to say something? No, but you might like it. And I started reading. I'm like, that's actually very helpful. Actually, it makes you feel bad to have to read large font, but it actually does read nicer that way when you get to be an old age. Nice. All right. The other day I was like trying to see how much of this one cleaner to use. Hey, what's going on?
Sorry to interrupt. Could I get Cambria across?
Cambria is not in this class. Sorry.
Oh, I'm sorry. Hannah Gustafson?
You can have her.
Sorry about that. Yeah,
All right.
thank you.
And so I had to hold the jug like, way out here. I felt like my dad used to mock him when he was my age, Can you see that yet, Dad? Can you see that? That was ridiculous. So, again, the average, we've done it a million times. Shh. Listen, the sample average is this guy. Again, sample. This is a statistic, is it not? That is, it is a characteristic of a sample. And what are we trying to say about these always? We're going to say something about the average from the population. So, in the future, I might want to know something about the average height of all 19-year-olds. This is mu, the Greek letter mu. Now, this is how you write it. You start like you're going to write an M, and you cross it with a U. Yeah. It's the Greek letter mu. Kind of a cross between a meow and a moo, I think. Okay? Now, anyway, again, this is from the population. Who knows that one? Only the good Lord knows, and He's probably the only one that cares. But I would like an idea, so I take a sample, yes? I compute the sample average, which by the way is a statistic, to make some statement about this parameter which I know nothing about. That will always be true. Be aware that in the chapter 3, I find it very annoying. Once in a while, they will throw this at you, and once in a while, they'll throw this one at you, and you're like, which is it, Mr. Groom? In this chapter, they treat them as if they were the same, which I find a little obnoxious, okay? But after this chapter, we get more specific about which one's which. So I will usually, if I'm doing a computation, I will usually just write it like this one, X bar, okay? But be aware, if you do, and then you go to the back of the book and it says mu, is that different? No, it's not. In this chapter, it's not, okay? But later on, it is a big deal. You do not compute the actual population average, ever. That's ridiculous. You compute a sample average, okay? And again, you're trying to make a statement about the actual population. Now, obviously, averages are affected by outliers, yes? All right? They're affected by outliers pretty greatly. I'll just write this in large amount, a lot. Yeah, they can be really affected by them. Now, I have better things to do than sit here and add up something all day long. Okay, I feel like we could this plus this plus this plus this. No big deal. We could do that all day. I don't want to. So I'm going to use a little Excel, if you don't mind, just to kind of show you the difference. Okay? And, yeah, I feel like it's not that hard to do. Now, since finding averages and medians and so forth, not very hard. We're not going to do a lot of them, unfortunately, for your grade, right? You're like, oh, give me a bunch of them, Mr. Groom. Oh, that's a nice one. Let's do one more. Oh, isn't that nice? Here's my set of data. Wouldn't it be cool? I'm saying, wouldn't this be so cool if you could, just tell the computer to find the average? You can. What? So the average is 6.33. Does that shock anybody? No, why not?
Because 6 is like in the middle.
Because 6 is less like in the middle. More importantly, though, is there any weirdo extreme values on this thing? Mm-mm. Let's look at the median. Equals median. Now there's 9 of them. Can you? There's 9 of them, so we already know the middle one would be number 5, yes? Which is the 6th one. And so, voila. Oh my gosh, they're like almost the same. Who'd have thunk it? But let's more. Let's put 100 right here. What? Mr. Hume, the middle one didn't change. You are correct. The middle one did not change because all I did was swap out one number for another number. The middle one is still the middle one. Okay? However, look at the average. It went from 6 to 16 or something, or whatever it was. That's quite a big jump. I don't think anybody's terribly shocked by this. So, yes? Yes? Okay, good. Everyone's asleep. That's amazing. Mr. Green, will we be using Excel for that? Not a ton. We will be finding averages, of course, later on. And of big data sets, no one expects you to do it by hand. Okay? But, yeah, we'll do a couple by hand here, and you'll see what I'm talking about as we get to them. Now, here's my next question. Here's my next question. I want to explore this median thing just a little bit more. And we said it's the 50th percentile. I'm just going to make up some data. Okay, good. Which one's the median?
6.
Yup. Here's some more data. Now what's the median? 7.5?
Yeah.
How did she get that? Because you average these two middle ones, yes? Now, the two middle ones, and that's how you've always done it. But today, friends, we're going to find out why that is. Okay? Now, I'm going to label these numbers as, this is the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one, yes? Oops. Fifth, fourth, third, first. Right? So there's 7 numbers, and I want the 50th percentile. When you see the number 7 and the number 0.5, what number comes to mind? 7 and 0.5, what number comes to mind? If you see the number at 7 and the other number 0.5, what do you think you're going to do with them? Oh, divide them. No, yeah, it'd be 14. That's weird. Okay, I don't think that's right.
Multiply them.
Multiply them. And what is 7 times 0.5? There are 7 terms times 3.5. That's weird. Oops, I'm sorry, times 0.5 is equal to 3.5. The 3.5 term, what? You just told me it was the 4th term that was the median. But this thing here says it should be the 3.5 term. 3.5 term. I don't even know what 3.5 term it even means, Mr. Groom. So how do we get the 4th term out of that then, you suppose? Well, before you answer, let's come down here. Down here there are a first, a second, a third, a fourth, a fifth, 6th, 7th, and 8th terms, yes? If you see the number 8 and the number 0.5 and you times them, what do you get? Well, you get 4. Wait a minute. The 4th term is just this fella, yes? Mm-hmm. How come you got that one and the next one? Do you think you can come up with a rule for me here, how this might work? Because up here we got the 3.5 term, and for some unknown reason we took the 4th term instead. And down here we got the 4th term, but somehow we took the 4th term and the 5th term. So, okay, what?
You add 0.5?
Okay, so on the first one, I don't know if I'm going to say I'm going to add 0.5, but maybe another way to think of that is rounding up. Yes? So if this rounds up, what do you get? Well, you get the 4th term. The 4th term. Well, that's cool. But this one down here came out even. It came out 4, yes? So how did we go from decide when you're going to do the fourth and the fifth term? What is that about, do you suppose? So up here it came out odd. I mean, not odd. It came out not a whole number. And we rounded it up. Down here we got a whole number. And we know that from back in grade school, someone told us to average those two numbers together. Okay? Well, here's the rule, friends. And by the way, this works for any percentile. Any percentile. You take the percentile, so 0.5 in this case, this is the percentile, times the number of terms. And it will equal n. Now listen, if, this is a big deal, if n is not a whole number, you will round up. That's what the big kids say. You round up. Always. 3.2, round it up, yo. 3.2. Okay, cool, the fourth term. Okay? If n is a whole number, then you average the nth term and the n plus 1th term. Now, this is why we make you take Algebra 2 before you take this course. In Algebra 2 and Pre-Cal, you've seen sequences and series. Some of you are like, I hit? Yes, you did. Really well? Maybe not. Did you pay attention? Yeah, probably not. But at some point you talked about this is the first term, second term, third term of the series. Yes? It's the same deal. So in this case up here, in the case of this one right here, we got 4. So it's the fourth term and the fifth term. We're going to average them. Well, the fourth one is this one, and the fifth one is this one. So when we average them, that's what we get out of the thing. Now for medians, it's not going to change. That's how medians have always worked. But Victoria wants to know, Mr. Groom, if I have this set of data, and she would like to know the 85th percentile. I'm not really sure why, but she wants to know it. First thing she's going to do is find out how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers there. So it's 10 numbers times your percentile. Comes out to be 8.5. What? What? Okay, so there's 10 numbers. Oh, I just pulled 85th out of my butt. Is that what you're asking about? Yeah. Listen, any number between 0 and 100 is okay. Between them, not equal to them. There is no such thing as the 0th percentile. Okay? And there's no such thing as the 100th percentile. But anything in between, knock yourself out. Stream, could you find the 1.7th percentile? Yes. Yes, you could. It's weird, but you could. So listen, this is the 8.5th term. That makes no sense. So the rule says, hey, round up, dog. If you round up, it's the 9th term. And what is the 9th term here? 26. That guy right there is the 85th percentile. Now, I know what Emily's thinking. Emily's thinking, I don't really care about the 85th percentile. I'd like to know what the 83rd percentile is. Huh? Good for you, though. She wants to know what the 83rd percentile is. And I said, I don't know. The formula says take this times this. 8.3. What? No, round up, dummy. So it's the 9th term. And what you will see is that usually for small data sets, there's going to be any one number could actually be considered several different percentiles. So in this case, number 20, this guy up here, whatever number he was, what was he? 26 is both the 83rd and the 85th percentile. It's true. There it is. And so we're going to see that as we go along. Okay? Not a big deal. Now, This is how your book teaches it, and that's how you do it old school, okay? Yes, Excel will actually find them, and I'm going to show you that later on when we get there. Excel has a slightly different menu for it, just like anything else. You look up online, recipe lemon meringue pie. Oh, Rachel Ray has one. Click, click. Oh, I like that. Back. All right. Oh, look, Emerald Lagasse has one too. Click, click. Oh my gosh, they're different. But they're both lemon meringue pie. So there are several recipes for finding this. This is how you do it with you doing it by hand, okay? It's not very hard. It's actually pretty easy. Now, as we mentioned the other day, we will be doing box plots in a few days. I'm not doing it today, but we will be doing it in a few days. So if you had some data, I'm going to make this data ugly. Mr. Grimm, isn't ugly in the eye of the beholder? It is. And I find it very disgusting. This problem is gross. Is it getting gross yet? Not yet. That's so gross. This kid obviously does not belong in this classroom. Everybody else is scoring 2s and 11% and crap, and this kid gets a 75. Okay. Or these are good kids. Number of referrals they get in their whole high school career, and then there's this idiot. Okay. So it could go either way. Let's find the median, shall we? What is the median here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, and 8. Yes, those two. I'm going to average them. You're like, could you show us the formula? 14 times 0.5 is 7. So I will average the 7th and 8th terms. Right? Good grief. And so when you average them, the 7th and 8th term, you get 6.5, correct? That is the median right there. Now we mentioned it the other day, the first quartile is the 25th percentile, yes? AKA. 25th percentile. Well, the formula says take your percentile times the number of data points, yes? That's what it says. And what is 14 times quota? It's 3.5, isn't it? You should probably check my math on that. I feel like that's right, though. Am I right? Hot dang. So the formula says you should always round up. So if you round up, I want the 4th term. 1, 2, 3, 4. This fella right here is the 25th percentile, or if you prefer, the first quartile. If you were taking a wild stab on this side, what do you think the 75th percentile or the 3rd quartile would be? What do you think it would be? I want one of these numbers. 10, based on what? Symmetry? Are you just going with like symmetry? Because it's like, yeah, you're right, actually. Check it out, dog. But 0.75 times 14, I don't know what that is. 3.5, 3.5, 3.5 is 10.5. 10.5, isn't it? I think that's right. Yay! And 10.5 rounds up to the 11th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, just like you called it, kid. Sure, can we always cheat and do it like that when we're doing percentiles by hand? Yeah. If you're doing 25th and 75th, yeah, they should be mirror images of each other. So if you find the one, just go over here and the other direction, you got it. Okay? Back when I was a kid, they always said, hey, look, if you split it right there, 1, 2, 3, 4, 5, 6, 7. Yes? Well, what does that make 10? Kind of makes 10 the middle of them, isn't it, right? If you split it right here at the median, that's how we were taught back in the day to find the quartiles. I don't really like it as well, because then what happens if it's a What happens, Mr. Groom, if the median is one of my numbers and it gets a little messier, it's not as pretty. So I like the percentile bit, because I can kill two birds with one stone, or one shotgun blast, if you will. Mr. Groom, I feel like not only quartiles are important, I bet, oops, and then I write percentiles, dadgummit. Deciles. What? What's a decile? What does it sound like, yo? Decimal, and what does decimal come from? Tens. So I'm probably interested in the 10th percentile, the 20th, and so forth. I mean, I don't need to bore you with this, but let's say if I want the second decile, isn't that just the same way you say 20th percentile, Mr. Groom? It is. So it's not this hard. So I don't know, 14 times 0.2 is 2.8, right? Check my math, is that right? Yes, feel like it is. And then I'm going to round up to the third term. The third term in my data set. Well, the third term in my data set is this fellow right here. So 4 right here, this guy, right, would be the 20th percentile, or the second decile, if you like. Okay? This stuff is not that terribly difficult. If you're weird and you want to find the 97th percentile, you can do this. It's not that hard to do. It's the same deal. 0.97 times 14, blah, blah, blah. That's all this stuff is. Okay? But what I want you to see is the median. The median, and oh, by the way, the median, since it's a percentile, and percentiles are not really affected by extremes, are they? So neither the median nor the percentiles are affected by outliers. Okay? Because that's all a median is a 50th percentile. All right? So if you have one outlier, extreme upper or lower, it's the first term or it's the last term, but it does not affect where the values are lying. Okay? If you just change the upper or the lower term to something weird or extreme, it's not going to affect what my percentiles are, my deciles, or whatever. And what I also want people to think about is this. Every year some kid gets freaked out. You wrote quartiles, percentile, decile. Yeah, that's great, Mr. Green. They're all percentiles. Okay? That's all they are. So the question is, what percentile? And so we say deciles because of 10 percentiles. 10, 20, 30, 40, 50 percentiles. Okay? Quartiles, obviously 25 and 75. Second quartiles is what? 50 percentile, aka the median. So not very difficult to do. Okay? So you'll see those as we go along. Yeah, it's not that hard to do. Obviously the most frequently occurring. If you need help with this one, we got problems. I don't think anybody will have a problem with this one. Most frequently occurring. Now, but listen, why would I want to know that? Why would I want to know which one's the most frequently occurring? Why would I want to know that, Dairy Queen girl? Like the average number of blah, blah, blah is whatever. The median number of whatever it is we're looking at, dilly bars, is blah, 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 blah. But the most frequently occurring...
Well, if we're going to talk about it very defense, you want to know how much of it you're selling.
There, well, how much of that you maybe should want to have on hand?
Yeah.
Kind of a big deal, right? So if there's one that sells out more than everything else, right? That's something we sell a ton of, right? Even though the average might be somewhere else, that's probably where you'd like to, make sure you stock plenty of that, okay? That's what it would happen if you're doing it for like a sales deal. Obviously, you can find some average and that's nice. But the most frequently occurring, you don't want to run out of stuff. Make sure you have that. Mr. Grimm, that feels like more than a number. Feels like almost a category. Right? So when I say like we never sell you should sell more of the butterscotch dilly bars, but you don't sell that because look at her, she's turning up her nose. Butterscotch is the best. If you have no problem, if you have a problem with butterscotch, you might have a problem. You want to go check that out. That's gross. Okay, you have a problem. But listen, it may be a situation where you're like, screw 'em, I'm running the Dairy Queen now, and my boss was stupid, and so I've decided that we're going to stock the same amount of every kind of dilly bar. When everybody knows you sell more chocolate than everything else. But you're like, I don't want to offend the poor butterscotch or something. And so we have to buy exactly, like, that's ridiculous, okay? But notice butterscotch, chocolate, strawberry, whatever they are, they're all categories, yes? But when I look at numerical values, that's where we get an actual mode from. Mode is only from numerical values. But if I say this number is the most frequently occurring, it's very similar to a category, yes? In that the most common thing, the most common number of referrals in a day for Mr. Hernley to look at is 10 or something. That's the most common number or whatever. So when he starts thinking about it on a daily basis, even though there might be some freakishly low days or high days, when he says to his wife after work, I'm going to be home at such and such a time, he's probably banking on the fact that most days he's going to have 10 referrals, all right? And then he looks at it more like a category, like what kind of dilly bar he's selling, okay? So from that standpoint, again, if you see a list of data and you cannot pick out just by looking what the median is, the mode is, you might have troubles. Now, the mode here is just this guy, yes? Just the 5s? What if there was only one 5, though? How many modes would there be? 1, 2, 3, 4, 5 modes, yes? Nice. Mr. Groom, if there's just one frequently occurring, or there's one in each, then there is no mode, yes? There is no most occurring. Which I know bothers some people because you'd say there's 4 here, Mr. Groom. But you'd say 0. Hi, how's it going? What do we got?
Lisa Jones.
Oh, sweet. Are you our new college person?
That's me.
Beautiful. There you go, Lisa.
Thanks.
Yep. All righty. So I don't remember where I was going with that. So yes, all right. So mode does occur. Yeah, Miss Munger is leaving. If you hadn't heard. Yeah. I didn't know. It's funny. The other day they said to me, Mr. Grimm. Oh no, they said something about we're hiring a new one. I'm like, for crying out loud, how many of those things do we need? And they're like, oh no, Mrs. Munger's leaving. I'm like, oh okay. Then I felt kind of bad because I thought we were hiring another one. And I'm like, geez, 2 of them? Come on, really? I don't know. She's moving. I didn't know. That's what they told me. I just said I work here. That's cool.